In this recording, we're going to learn about arithmetic and geometric sequences. So if that's new to you, basically there's two particular kind of sequences that are named, and arithmetic is based on constant addition. So if you just think arithmetic add, geometric is constant multiplication. So geometric has to do with multiplying by something to get to the next term. So let's start with arithmetic. So if you have a recursive definition, that means we're based always on the previous term for an arithmetic sequence. We have here the first term. We have to know the first term because we have to know where to start, right? And then we have to know what we're going to add on each time. Okay, and this common difference is called D. Okay, and D is here as well. So first let's look at a form is using a function notation. So given what the value of the first term is f of 1. If you want to find another term, f of n, you simply take the previous term and add on the difference. So it looks kind of complicated. We'll get familiar with it. This is known as the previous term, right? Because the value of the subscript, or the term's identifier, the position of the term, is one less than the term we're on. Similar with our subscript notation. Okay, if we're given the first term, okay, that gets us started. Now we can find more terms by taking the previous term, that's a sub n minus 1, and adding on this common difference. And obviously the common difference could be positive or negative, which could make the terms go up or down. So let's play with that a little bit here in this first exercise. So it wants us to generate the next three terms. Why don't you try your hand at that? Why don't you try to identify the second term, third term, and fourth term, given this function definition, which says we're starting at 2, and it's telling us here, okay, if you want to find the next term, take the previous term and add 6. Play the recording when you're ready. So if you did that, so our second term is going to be the same as f of 1 plus 6, right? Because if 2 is n of f of 2 minus 1 is simply f of 1. So you're going to add on 6 to the previous term. So 2 plus 6, you get 8. So the next term is 8 plus 6. And then finally, so I think you can see what's going on here. We start with 2, then 8, then 14, then 20. We are adding on a common difference. Do part B and then play the recording when you're ready. Okay, so part B uses subscript notation. We want you to be fluent in both notations. Just like you know for multiplication, there's like a star, if I can make one, and there's also a dot, and there's parentheses, right? Lots of ways to communicate multiplication. Similarly, there's multiple ways to define a sequence. So if I want to find the second term, third term, and fourth term, I'm just going to follow this definition. Okay, so this one says add on half to the previous term. This next question is a problem-solving question. So why don't you read it over and try to make sense out of it a little bit, and then play the recording when you're ready for more. Okay, so it does not give us the common difference, doesn't even give us any terms. And so one way to think about it is like, well, what could t be? Well, let's let t be a number like 1. Just sub in 1 and just see what's going on here. So if I sub in a 1, 2 times 1 is 2, 5 times 1 is 5, minus 1 is 4, 6 times 1 plus 2, that's 8. So actually that doesn't look right, right? 2, 4, 8, it does not look like it has a common difference. It is not arithmetic. So clearly, if this is an arithmetic sequence, which it says it is, and by the way, that's how we pronounce it. You might be looking at it like, isn't it supposed to be arithmetic? Is he saying it weird? Arithmetic is a noun, but arithmetic is the adjective we use to describe a particular kind of sequence that has a common difference, or adding each time. Okay, so all right, we know that t is not 1. Well, we could try other numbers, or we could just simply work this out. So here's what we do know. If there's a common difference, the first term, let's call that a sub 1, second term, third term, the difference here between the first two must be the same difference as the second and third. So a sub 2 minus a sub 1 had better be the same as a sub 3 minus a sub 2, right? So we just sub in. Got to be careful here how you make this substitution, though. The whole expression, let's put parentheses here just to show it. The whole expression of a sub 3 subtracting the whole expression of a sub 1, the second term. Got to have parentheses here, or we won't get the signs right. So again, just distribute and do the subtraction and solve out. So we now found out that the value of t is not, in fact, 1. That didn't work. It's 2. Let's confirm that that works. So I'm going to sub in a t equals 2 into these three terms. So the first term would be a 4, right? Next term, 5 times 2 is 10 minus 1. That would be a 9. Okay? So far I've got a difference of 5. We better have another difference of 5. Let's check it out. So 6 times 2 is 12 plus 2 is 14. That does look like it's going to work. Difference of 5. So want to know what's the value of the fourth term. All right, well, I can figure that out, right? Just continue that pattern. Add 5, add 5, add 5. The fourth term has to be 19. Okay, challenging question there. Hopefully that all made sense. Okay, now we're going to try to generalize from a recursive formula. This one is recursive. Gives us the value of the first term, gives us the pattern to follow. We're going to add on 3 to the previous term. But it doesn't allow us to easily jump to, for example, the 50th term, which is what we're trying to do in part C here. Okay, so this is, again, a recursive formula. It has its value because it's easy to write, but it's difficult to jump to a particular term that is big. So let's find the value of the first, or the second, third, and fourth term. Play the recording when you're ready. So if you paused and work these out. Okay, so the second term is based on the first. The one before it plus 3. You got a 5 plus a 3, that should be an 8. Okay, the third term is based on taking the term before it, which is an 8, plus a 3 is 11. Fourth term. Term that came before it plus a 3, so 11 plus a 3 is 14. Okay, so I can see the difference is 3 each time. It goes 5, 8, 11, 14. Cool. So now it asks, this is a little bit of a discovery, right? We're trying to discover how to do this thing. How to jump to the 50th term without really working that all out. So if we're adding 3 each time, how many times do we add 3 to 5 in order to produce a sub 4, fourth term? Well, check it out. We add it once. Let's just write these out. So we have 5, 8, 11, 14. So it jumped once, twice, 3 times actually. To get to the fourth term, we needed to add 3 to 5 3 times. Okay, so there's a mistake here that I want you to avoid. A common misconception is that to get to the fourth term, it's supposed to say fourth term there, we would be adding 3 4 times. But just think about it. When you're playing a board game like Monopoly or something, when you roll a 4, you go ahead 4 spaces, right? If you don't end up on the 4th square, you end up on the 5th square because you're starting on square 1. Okay, so it's always going to be 1 less than the term number that we're trying to get to. So I'm trying to get to the 50th term. Just think for a second. How many times would I need to add 3? And hopefully you recognize it's got to be 1 less. It's got to be 49 times. So a sub 50 is pretty easy to figure out once I understand the pattern. It's just start with the first term and add 3 one less amount of times, so 49 times. And just do the math there. Okay, so in part D, we're going to generalize here. And we say, okay, if I want to get to the nth term, okay, what do I need? I need the first term. That's my 5. I've got to have a starting point. Then I'm going to be adding on something. That's the D, right? That's the 3 in this case. I'm going to be adding on, make that a sub 1, add on the common difference. How many times? Just think about what we just talked about. 49 times if I want to get to the 50th term. So I'm going to add on n minus 1 times if I want to get to the nth term. That's the explicit formula for an arithmetic sequence. You could also hear a explicit rule, definition. Any other words? There's another phrase I'm not thinking of right now, but there's at least 3 ways to say this, and this is for an arithmetic sequence, where we're adding. So for our final question about arithmetic sequences, we have a challenge here. We're given that the first term is 6, fourth term is 18. What's the 20th term? Well, that's going to be hard to do because we don't even know, like, what's the pattern, right? All we know is that the first and fourth term are given. So let's do a little layout. There's a couple ways to do this. One involves the formula, and one involves just sort of some intuition. I'm going to show you both ways. So let's put in what we know. The first term and the fourth term. The second and third are unknown. Okay, so we got the 6 and 18. Take a moment right now to see if you can do some figuring to figure out the middle two, and play the recording when you're ready. Okay, hopefully you paused and worked that out. Well, it goes up 12, right? It goes up 12 overall to go from 6 to 18. And whatever this is, this difference, this adding amount, that's what we're adding on, plus d each time. D is unknown. But I can see pretty clear that I'm adding it on 3 times, right? So 3d has to give me 12, and obviously that works out to be d is 4. So once that's known, I could continue this pattern out, or I could use my formula. Well, let's figure for a second another way. I'm going to show you another way. We've got our explicit formula, a sub n equals the first term plus the common difference added on n minus 1 amount of times. Let's sub in what we know. For the fourth term, that'd be a sub 4. 18 is its value. Okay, the first term is given to be 6. The d is unknown, that difference is unknown, but I do know that if I'm on the fourth term, n would be 4, so it's going to be a 4 minus 1. At this point, we can work this out. So that's a 3 times d. And when we add, when we subtract from both sides, we've got 12 equals 3d, and then we're back to where we found d is 4. Same value. Now it's pretty much, okay, work out and find the 20th term. So play the recording when you think you found the 20th term. Do it any way you can. I hope you found out that we start with the first term. We add on the d n minus 1 amount of time, so it'd be 19, right? You just got to do a little math there. Works out to be 82. Thanks for watching.